In Amsterdam, the electric mobility sector is booming. Next year, we expect over 5,000 electric vehicles on the roads.
For the system to run smoothly, we need increased balancing capabilities, not only on a national level, like the transmission system operator's responsibility, but also on a local level.
Here at CWI, which is the Dutch National Research Center for Mathematics and Computer Science, we're doing work on simulations that would explore the feasibility of flexibility.
Since 2011, various companies have started up who are running electric vehicles in the city and providing new mobility options for Amsterdam people. We are expecting more and more electric vehicles to be connected, sometimes at the same time. This can cause a problem. As we are approaching the system's limits, we need to take action. We can either put more copper in the ground, expand the capacity of the network, or come up with something more intelligently. A smart grid.
We're in the middle of a transition towards sustainable energy. So we want our energy to be cheap and reliable, but also green. Now, solar and wind energy are going to be an important component in this solution. But there is an obvious problem. Weather, we can't control it, and storage is not always an option.
So we have two phenomena occurring at the same time. On the one hand, we have an increased penetration of renewable energy generation through solar and wind, and that introduces fluctuations in the supply. At the same time, there may be other areas where you have a lot of electric vehicles, and if everyone comes home from work and plugs in their electric vehicle, then we may have a strong peak, an increased peak over the normal peaks we have in the evening hours anyway. And we find increasing network congestion and transmission losses.
So smart grids are trying to address this problem in a different way. One of the possible solutions is demand response. The idea of demand response is that not all the loads on the energy grid are equally urgent. Some loads can be shifted to a later time slot. And that flexibility becomes valuable, because producing energy at peak times is very expensive.
In the last few years, we came up with a dedicated research platform called Market Garden. In it, we simulate both the grid side and the market side. We know the usage patterns of cars. We have models for retail operation. We have models for wholesale market mechanisms and distribution system operators. We know how the power flows through the network. We know the weather patterns to simulate solar panels. We have models for the electric vehicles and all kinds of nodes and agents in the simulation.
In one of our case studies, we're looking at the Amsterdam grid. The Amsterdam grid provides a specific local opportunity to fuel the cars with locally generated resources, for example, through an electric vehicle aggregator.
EVA, the electric vehicle aggregator, is all about gathering the flexibility in the charging of the electric vehicles and combining that into a service that you can provide to other parties connected to the electricity grid. EVA is a collaboration between CWI and TU Berlin under the EIT ICT labs.
We think that in the future each household will own at least one EV. Therefore, Sense Chair of TU Berlin works with driving patterns from German field studies. These profiles can be decoded to different user groups and reasons. This was the basis for our EVA business models, in which we implemented business users as well as commuters.
Using our dedicated platform, we've already been able to do simulations on two business cases: Amsterdam Taxi Electric and Volkswagen factory in Wolfsburg.
Well, we spend a lot of money on the cables under the ground here because we do not use any smart charging at the moment. But if we could use this in the future, we need less cables, which means higher profit in the end. Even if we expand to 100 cars in the future. We want to change the system, and smart charging is part of it.
What we are doing here is trying to provide a balancing solution on a local level. We are primarily using local energy markets in order to bring supply and consumption together. Specifically, this means that our energy, the fuel of our cars, is green and it's cheap.
Currently we're doing this research with ICT labs and at the Technical University in Berlin, but we are constantly looking for new partners in our network because they might bring to the table new application cases, which might be challenging problem for us and interesting revenue applications for them. So if you're interested, please do contact us.
We would be glad to extend our simulations to your application case.